we're going to take the Pythagorean theorem and write down its converse, the reverse of the Pythagorean theorem, because it turns out that it is also true and very useful as well. So I just carved out some space here. So let's call this converse of the Pythagorean theorem. Converse of the Pythagorean theorem. Okay. And so we're going to reverse this statement. So this statement starts off, if you have a right triangle, then the legs and with the legs A and B and the hypotenuse C, then A squared plus B squared equals C squared. We're going to reverse it. So this is going to become our hypothesis. So we're going to start with if in a triangle the sides follow. So let me just write that down. If in a triangle, because we have to have a triangle, the sides follow A squared plus B squared equals C squared, then, well, let's go back to our original theorem, because what used to be the hypothesis, what we started with, is going to be our conclusion. What was our hypothesis here? What do we have to have? Yeah. Well, let's just end with this, because that's the main thing. This other stuff, legs A and B, I mean, I could have named the legs anything, right? But it turns out that A, B, and C is the most common here in America for that. But what do we get as a conclusion? Then we have a right triangle. So that's what we have here. Then it is a right triangle. Okay. So what does this mean? This means without looking at the triangle, if you tell me the lengths of the sides, I can tell you if it will be a right triangle or not. And when you get into geometry, you add a little more and you can tell if it's an acute or an obtuse triangle. Yes, Jesse. Oh, okay. So this is what we're going to use today, and it's super, super easy. All right. What this allows us to do is the following. Here it is. Determine if the three sides form a right triangle. And again, okay, so let me give you the first one. Let's say the sides of our triangle are 12. Let's give them centimeters, 17 centimeters, and 9 centimeters. Okay. Let's say those are the lengths. What we want to do is same as if we were looking at our triangle with lengths. One of them has to be C. Which one has to be C? 17, the longest side, even if it's not the last one. So it has to be our potential hypotenuse. So that one has to be C. It's the longest one. and then just make the other ones A and B. Okay? And what we're going to do is, well, we're going to try out a squared plus b squared and compare it to c squared. This part we don't know what goes in here. If it's an equal sign that goes in between, it's a right triangle. If it's something else, it's not a right triangle. Okay, well, plug-in time. So we have 12 squared plus 9 squared. And we're going to compare it to 17 squared. So this is 144 plus 81. And we're going to compare it to 289. Is that going to be an equal sign there? No. Therefore, not a right triangle. Okay. Let's do one more. .1 miles. 2.8 miles. And 3.5 miles. Okay. Which one has to be C? Yeah, 3.5 has to be C. So these will be A and B. And we'll do the same thing, compare. 2.1 squared plus 2.8 squared compared to 3.5 squared. This part we don't know yet. We'll just leave it open. So this is 4.41. $7.84. And 12.25. Okay. So 4.41 plus 7.84. Does it add up to 12.25? It sure does. This one is definitely equal. Therefore, it is a right triangle. So on today's assignment, it's an IXL. They're going to be doing this. Presenting you with 3 possible sides of a right triangle, and it's either yes or a no.